Hello, I'm Krutoo and today we are going to look at question 8 from the paper P4 of Math IAL 2020 June. This one is vector, as you can see, and I find a lot of students are more on the less side comfortable with vector problems. So today we'll look at it. So for this question, let's look at problem A first, which finished at this point. So they say that relative to a fixed origin O, the line L1 and L2 are given by the equations as follows. So the first one is governed by the variable lambda and the second one is governed by the variable mu. They said that L1 and L2 will meet at the point X. We have to find the position vector of point X. So let me grab this and put it on another page. Okay. This one is 5 points, but I think it is relatively on the easier side. If the two lines were to meet, it has to meet at the same coordinate. So we can use this logic to match the x coordinate and then the y coordinate and then the z coordinate of each line. So if x coordinate were to be the same, then 4 plus 3 lambda must be equal to 2 plus 2 mu. Okay, and if the y coordinate, by the way, this is the x coordinate, the y coordinate has to be the same, then negative 3 minus 2 lambda must be the same as negative mu. Okay, so let's take this and rearrange it a little bit. So if I rearrange the equation for x, I'll have 3 lambda minus 2 mu equals minus 2. Okay, so that goes to that side. And for this one, I'll have minus 2 lambda, for this equation, minus 2 lambda plus mu and then equals 3. And in order to solve this, I can easily take the second equation, times it by 2, and I'll get negative 4 lambda plus 2 mu equals 6. And then I'll take this equation and add them together. If I add them together, I'll get negative lambda and then the mu term will be gone, and then I'll get this to be 4, which means that lambda equals negative 4. And if lambda equals negative 4, I can plug it back in somewhere. I'm going to plug it back in here. So I have negative 2 times negative 4 plus mu equals 3. So this will be 8 plus mu equals 3, which means that mu has to be negative 5. Okay, let me get rid of this quickly. Since now we have our mu and lambda, we can plug this value of mu and lambda back into here to find the coordinate, and they will all be the same thing. So let me show you. So this will be 3 minus 2, 2, right? The first one. Plus, so the lambda is going to be minus 4, and this is 3 minus 2 minus 1. So this is going to be 4 plus negative 12, which is negative 8. This is going to be minus 3 plus, this is going to be 8, which is 5. And then the last one is going to be 2 plus 4, which is going to be 6. So that should be our answer. But let's test it with the other one. So the other one is 2, 0, minus 9, but then you have to add it with negative 5 as a mu value, right? And then times it by 2 minus 1 minus 3. So the first one is going to be 2 minus 10 gets you minus 8, and that is going to be minus 5 times 1, which is also 5, and then minus 9, and this one is going to be plus 15, so 15 minus 9 gets you 6. Okay, we get the same answer, which means this is the correct answer and this is the point X where the two lines intersect.